Hello and thank you for watching. In this tutorial, I'm going to show you how to use regression analysis to predict stock prices. So I completed this project a couple weeks ago for a school project. So I wanted to share with you guys on exactly what I did for this analysis. So the goal of this project is to predict stock market prices and discover future revenue. So an accurate prediction can lead to more profit owners can make, but predicting stock prices can be a very difficult task. And it's due to several issues that revolve around stock prediction, such as economic growth, politics, and interest rates, which make accurate predictions very hard to accomplish. But with machine learning, it has been used by many experts to effectively perform stock price predictions, and a successful future prediction can produce a significant profit. So we're going to go ahead and use regression analysis and see if we can predict stock prices. So the first thing is importing your libraries into Python. So that's what I did here. Here in these brackets, it's blank, but once you hit the run button, it's going to show a star, meaning that it is running. And then once you see a number, it means it went through successfully. So I'm going to keep on running down here. As you can see, I am loading the CSV file and reading the data set. So we're going to use Google data. And this data I pulled from Kaggle.com. So Kaggle.com is a place you can go and pull open source data sets. And it's very good, especially if you're trying to learn how to do a data analysis and you need data sets to accomplish that. They have all sorts of data sets you can use, and it's Kaggle.com. So using this code here, it's going to read my data. This is my data file, kaggle.csv, and I'm going to name it df. So then I run the df.head, which shows all my variables and all of my data. So there's a date, a close price, high price, a low price, open price. So this is all stock data. So if you use another data set that has similar variables, it will work just fine. You can just upload it here and use this same data analysis. So next I'm going to identify the shape of the data. So I run that by using df.shape. And there's the shape of my data. So it shows I have 14 variables. And then I'm going to run a data preparation. So in this part here, I dropped some variables that I do not need. So I'm dropping the symbol, adjusted close, adjusted high. As you can see here, all these, basically these ones at the end, I'm dropping from this data set. And I print the new data set, the df.head, and this is what is left. So these are the variables that I really need for this analysis. So then next I'm going to clean my data. So I'm going to check for any duplicates. And it's false, meaning I do not have any duplicate values. Next I'm doing checking for any null values in my data set. So the df dot is null. It's false, meaning I have no null values. And then the next step, I'm going to run my df.info. So this here, I'm checking and reviewing the data frame information. So it's giving me the columns, which is the date, close, high. And each column, it's showing me if it's non-null and the data type. So it's object, the close, since it's a date, The close is a float. Same with high. All these are all prices. So it's float, and then the volume is integer. So that's how to check your data frame. So I'm going to run the next one, which is the df.describe. So this shows the count, mean, standard deviation. So for each variable, so close, high, low, open, and volume. So there's the mean for each one of those, standard deviations. And the next thing I'm going to do, I'm going to check for correlations between all columns. So that's showing the relationships, like what's the closest. So as you can see, close has a 1. High is a 9.99. So it looks like these are all pretty close correlations. And that's what makes your regression analysis prediction more accurate, when you have variables that are more closer in correlation. So next I'm going to go ahead and put in a heat map. So more of a visualization of correlation. So it shows your variables here on the side, on the bottom, and then each of their correlations. As you can see, the volume has less of a correlation compared to all of the open, low, high, and close. And next, I did a visualization overview of relationships in the data. So I'm going to run these. So this one here is a pair plot. So it shows a variety of plots for each variable and their visualization correlations. And you can see that the linear regression is very linear for the closing. This one here, more of a scatter plot on the side, is more like the volume. See here, and up on this side is here. So that's how to do your visualization overview with a pair plot, which is very cool to use. And some more visualizations. I did a histogram for open. So again, that's our data set name, df, and then that's the variable name, open. So I'm looking at a visual there. And I did it for each variable. I did it for high and low and close and volume, all the histograms. And then here I did a box plot to see any outliers. So in this box plot, you can see I did the open, high, low, and close variables. And these are all the box plot for those variables. And you can see a lot of outliers here, but the outliers, I had indicated in my project that there's nothing significant that needs to be adjusted or any issues with these, because they all go up to like the same amount. And also with stock prices, the amount can differ. You know, it can be a very large amount, a very low amount. So that's the thing with stock prices, they can be up and high. And then next I went ahead and did the I plotted the data. I did a double click here. So this is the Google price analysis here. So plotting this data shows like the prices, and it goes up in an upward trend. So as you can see, there's the green and the red. And if you go over it, it shows a pop-up of high, open, low, close variables and the date for each of those prices. And if you look at the code, it shows, I'm grabbing the date, so it shows the date on the bottom and each of those variables. And then there's the open and low. But it does show an upward trend between June 14, 2016, all the way up to May 20th, 2021. So that's the trend of the data. So now that we did a lot of cleaning and visualizations for the data, now we can split the data set to get it ready for regression analysis. So splitting the data, as you can see, that my x-axis is going to be the open, high, low, and volume. These are my independent variables. And my y-axis is going to be just the close. So that's going to be my dependent variable. So my dependent and my independent variables. The next thing I'm going to run is splitting the data into 80% train and 20% testing. So with this code here, I am splitting it. That's why I put the 0.2, which means 20% for testing. So once I did that, I went ahead and printed out the train and the test. So it shows me 1,006 for train and 252 were testing. So next what we're doing here is we're going to train the model for the linear regression. So this is creating the regression model. And then we're going to fit the linear regression model. And we're going to call it model regression.fit. So that's where this comes from, that regression, and right there. And then this is the X train, Y train. So I ran that and it went through successfully. And now we're going to start with our predictions. So creating this to do our prediction. With the test prediction complete, the next step will better compare them with the actual output values for X test by organizing them in a data frame format. So once I did the regression.predict for X train, I'm going to call that predicted, and I'm going to print out the predicted shape. So 252, as you can see, if I go back up here to the top, it's the same price as our X test. Now we're going to validate the model of the fit. So here's your coefficients. There's 1, 2, 3, 4 coefficients and 1 intercept. Then we do the prediction table of actual prices versus predicted values. So just to get a visualization of these. So now there's 2 columns, which is the actual price and the predicted price. So this predicted price looks like it's pretty close to the actual prices, as you can see, just going down. And as you can see, I also called this prediction a DFR. So now I'm going to read the stats on those predictions of each of those variables, those 2 columns. So there's actual price and predicted price. And again, there's your count, mean, standard deviation for each of those columns. So I'm going to do this one here. So this is a difference of Y test values, subtracting the prediction value. So here we are creating this visualization to get our hypothesis. We can pretty much see if our hypothesis is true. So since it's really close to 0, it means that it is true. So if it was outwards, lower down here, or upward, it would be not true. It would be a null hypothesis. And then next is checking our p-value. So again, same thing as what the p-values are used for, is checking to see if it's a null hypothesis or if we reject it or keep it. So printing out our p-value. This is our p-value here. And another way of doing this, reviewing your p-values, is printing out your OLS regression results. This shows all of your information within your data set. So it gives you your coefficient, standard deviation error, there's your t-test, a p-value, and the p-values look pretty good. They're all under 0.05. So anything under that is a good p-value. And those look all good. So now we're going to go ahead and run the linear regression, the confidence. And it's at 0.99, which is 99%, or I say 100% because we round it up. And then the fun part is, haven't got there yet. So now we go to the mean absolute error, the mean square error, and the root mean square error. So this is how you print that. And then your model accuracy. So if you run this, the accuracy for the model is 99.59%. And then we check for the linear. It looks really good, the actual price and the predicted price for those two rows or those two columns. So it looks pretty good. So now we'll go ahead and do our visualization with the histogram plot and check more visualizing. And it's, as you can see, again, these prices are very, very, very close to each other. So the blue is actual price and the orange is predicted price. So this is how you predict stock prices using regression analysis. I hope you enjoyed the video. Give me a thumbs up. And if you haven't subscribed, make sure to subscribe. Thanks again.